going to approach this presentation is a bit different. I'll try to show you some of the work we've done over the past 3 years, and in that way show how we try to use new technologies to make things not just more efficient, but also more beautiful. So I'll start out with the world around us the way it was when we graduated. It was 3 years ago, a time of great optimism, infinite possibilities in the digital realm, but I was studying architecture, and the reality there was more like this. So very conservative, repetitive, everything was industrialized. So I actually left industrial design because I thought I didn't want to make mass-produced objects. And I kind of fell into a trap when I went to study architecture. So when I saw the projects going on there, I was wondering about the future I would have in this sector. Because designing this, spending 3, 4, 10 years on a project, and then seeing people kind of turn their heads when they see it or experience it was really something I wasn't looking forward to. But there were other examples, like fascinating architects like Frank Gehry, who showed that architecture can be beautiful, it can evoke emotions, it can make people happy. But the problem with those is that it also bankrupts cities, and that it's made super inefficiently. So, and I saw this happening in a world where actually the possibilities for manufacturing were becoming more and more accessible. So for 20, 30 years, these machines were already being applied in the automotive industry. So for serial mass production. But we thought, why can't we apply this to the construction industry? I mean, these are also mass-produced elements. So together with 2 of my fellow students, we started a company right after graduating in the middle of the crisis. That was a pretty good idea. Called RAP, Robotics, Architecture and Production. We thought let's give it a name that suits, but we get a lot of requests for people who want to record their albums at us, so that doesn't really work. But anyway, it will stay there. And our ambition was really not just to make beautiful projects, but also to make them efficiently. So not bankrupt the client, but also not stick them with a building that will be very ugly for the coming 40 years. So how we wanted to do this was to connect 2 things. So talking about the other side, to connect the digital design to a digital fabrication. So that means that you're not just making a sketch and then sending it to a production company who thinks, okay, I'll see how I'll manufacture this in the way most efficient for me, but to make a design that seamlessly integrates with the production that will make it eventually, to not cut the umbilical cord. And we wanted to do this with industrial robot arms because these things are super cheap, they're accessible, you can get one for like 10,000 euros, a second-hand one, and it's just like your own arm. You put a new tool in it, you've got yourself a new machine. So for us, looking for experiment, for innovation, this was really the way to start out. And like you heard, we found a scrap robot in the Innovation Dock in Rotterdam. And for us, that was the start of our adventure. And that's also where we got our first assignment. So I'll show you some projects just to give you an image of how we work. So the project is called Skilled In. It was made for the Port of Rotterdam, who was then our landlord, and they were kind of fed up that we weren't paying the rent, and they said maybe you can make something to pay in natura. And this is a small video explaining how it works. So we started out with a design that is not a napkin sketch or like a brilliant image we saw somewhere, but it's actually a completely optimized wooden dome where all of the fabrication data is actually generated automatically in this model, simulated for the production methods we had available at that moment. We actually only had 1 robot, so we had to deal with that. And we manufactured in the place where we rented ourselves, so we could just bring the stuff to the work site in a couple of minutes. And the nice thing about this machine is that the equivalent of this would be a 5-axis milling machine worth about 8 or 900,000 euros, and we did the whole project for about 50,000 euros. So for us as a small company, 3 guys with just student debt, it was actually a really nice way to get started. And the result, as you can see, is something that's not just organic, but it has really nice craftsmanship in it. We call it digital craftsmanship because it's something that comes out of this process where we design with the production and the end in mind. So we also assembled this ourselves. We paid for all the money with advances from our parents and Duo. And with this first project, we won the Nederlandse Bouwprijs, and a lot of architects frowned at that. They were like, "It's not a building. This is not proper architecture." But the jury really saw that this is not about the end result. This is about a completely different process where a designer is not just making a nice drawing and designing the look and feel, but really looking forward to the production and use of the building. And which also results in really, really nice details. So we're not trying to hide anything, but all of the time and effort we put into engineering these things is really showing off. And it's manufactured in a completely standard way. Like milling has been around for decades. It just wasn't applied like this yet. And you get small bonus features because wood is stronger in one direction, and you can see that in the laminate of the wood. So in that direction. And when we were assembling this this piece, we saw that all of these nerves were lining up with the structure. So then in the end, you sort of get this radiant feeling, which now everybody unfortunately calls the fountain. But from this project, we're looking forward. So normally you make a design, after that you're done, you go on to the next project. But what we've developed is actually a process, so a workflow, where now our client has come back to us and has requested, okay, can you also build 10 of these, but then outside and 4 times as large? And because this is a compression-only structure, like the Sagrada Familia by Gaudi, you can expand them almost infinitely without making the material any thicker. So this hyper-efficient design is also expandable and efficient for us as well, because maybe with this project we'll finally make some money. Then to test this workflow, really just to make ourselves better at this, we did a project for the municipality of The Hague, where they asked us to make a spiral staircase or a staircase as an escape route from the raadzaal, so where decisions are being made. And so we made, we think, the most beautiful escape chair of Holland, at least. And what we did here was testing the speed and flexibility of our processes. This was something where a normal contractor wasn't invited because they had 6 weeks to go from a sketch to actual delivery. And because we do everything ourselves, we could do this. Like if you hire a contractor, the talks will take 5 weeks. So in this way, we really noticed that we've got something here, because speed is very important in this current economy. From this project, people saw it, and not just locally, so not just in Rotterdam or The Hague. We went to Tokyo to design a beautiful restaurant, temporary, from recycled materials, where we show that these digitally inspired techniques and robotic manufacturing don't mean a technical, orthogonal aesthetic. It can be organic, sensual, it can enhance the experience of eating high quality food. And in that way, we showed that these techniques can be exported. I mean, these robots are also in Tokyo. It's not like we have to manufacture everything in Rotterdam. So after these 2 smaller jobs, we were asked to look at the circular pavilion, which is here in Amsterdam at the Malerplein. And this is a pavilion where everything is about reuse, controlling waste streams. And they told us, yeah, we really liked what you did with your previous projects, but could you do something for us? So we analyzed the building process they were doing at the moment, and they said, yeah, there's no waste. Everything is completely circular. But when we went to the actual company who was producing this building, so the wooden beams, we saw that they had huge quantities of wood which were standing outside, just outside of their company, and they told us, yeah, it's just a little bit too warped or too bendy, so we can't use it anymore. So we had this idea, like, okay, how can we improve the acoustics of this building, because it's a concrete box in the bottom, while using this reclaimed wood. And that's when we thought about the circular experience. So in this project we started out with 2 different materials, so 2 different types of wood. And we designed acoustic wall elements and balustrades for them, where we kind of wanted to show off how complex work machines can make. It had to be completely circular, so all of the connections are like IKEA dowel elements, so you can take it apart and separate wood and steel at the end. And we built a completely custom production process for this. So almost for every project we do, we try to think of new materials, new ways of using these robotic arms we have. And in the end, it's like giving somebody the job to assemble 60,000 little pieces of wood and only paying them €1 an hour. So maybe this is where the ethics comes in. So here you see a time lapse of the machine assembling it. And the nice thing about it is that all of these elements are unique, but because you're making everything in a computer from the beginning, you never have to put this onto a drawing. I mean, we don't want to draw 60,000 pieces of wood. But what we experienced in this project is that it was all fun and games in the beginning, but when you have to do fire tests, load-bearing tests, suddenly these projects can become pretty intense. But an added benefit of this technology was that because it has 60,000 small elements, if one breaks, the rest is still fine. So it actually performs really, really well. And these machines have now been sold to a company who produces fences. So actually this business model that I was talking about kind of changed in the past years, because a company saw this, he thought, oh, there's guys doing this for about 8 hours a day at my company. When we put this robot next to them, they can make about 6 to 7 times as many pieces. So we saw that the technology that we were developing was actually also valuable for industry. But in the end, for us, what matters is that it's not just efficient or technologically innovative, but that it looks really nice. In the end, we want to show that there's a new aesthetic in technology, not just more efficient, but also more beautiful. So what you see is that this handrail is actually informing the entire design. So where the handrail is close to the elements, there the elements are flush, and the further away it comes, the elements sort of waver out. So this is a completely parametric dynamic design, but it's very, very craftsman-like. So you would never get this type of detail from a large manufacturing firm. And so this is the last project I'm going to show you before the next speaker is up. This is a project we're working on right now. We don't just work with wood. That was a comment we had a lot, so we wanted to So we wanted to sort of switch gears. We started working together with a large concrete manufacturer, and we got the assignment to make 40 water taxi stops in Rotterdam. So these water taxi stops connect different parts of the city. So they can be hugely crowded at the Rotterdam, or there's maybe one person there once a month. So these places are hugely different, and that's where this parametric design that we use, computational design, really comes in. Because for a machine, it doesn't really matter whether it's doing 40 times the same thing or 40 times something different. It's all in the instructions. So if you make a dynamic design, you can make a completely new project every time from one mother model. So we experimented with this. We made some early tests with color and gradients and those kinds of things, and then we made a parametric model. So this is actually a bus stop design which can be adapted for every different location. So you have a lot of visitors, we make it very big. You have a lot of southwest wind, we make it very much embracing. There's not so much wind load, we open it up almost completely. So we made this design for it. which is using steel wires to reinforce this concrete material. We're expecting 3D printed concrete to reach the market in about a year, but we're actually delivering this project right now because we're not using any reinforcement. And the idea is still the same. This is a machine, you tie a tool to it, it's like a slagroomspuit, and yeah, you know what I mean. And in the end, it's still the same. We're sending it instruction on where to go and when to turn this pump on and off. So it's really quite basic. But in the end, you can make all of these different elements with it. We're testing whether we can carry them, whether we can place them right now. And the nice thing about this is from these first tests, we've already gotten the assignment to make another 20 of these in a city I cannot disclose yet, but it's in Holland. So what I wanted to show you with this is that tying a digital design to digital manufacturing methods doesn't mean that you can just work faster or more efficient, but that you can make more beautiful things.